Welcome back to it. It's Maths Masterclass with Leo. Today we are doing calculus, engineering maths 1, and our focus area is on calculus. Right? Calculus, and we're starting with partial fractions. Partial fractions, one of the easiest topics when you understand the introduction or the basics of it, right? So we'll be starting with the basics of partial fractions and then moving to problem solving, right? So without any further waste of time, let's say given a rational expression in the form, f of x is equals to p of x over q of x. You are given this, right, where p of x and q of x, are polynomials, right? You are given this where p of x and q of x are polynomials, and the degree of p of x is smaller when compared to the degree of q of x, right? Now, p of x and q of x are polynomials, and the degree of p of x is smaller than the degree of q of x, right? The degree we're talking about that exponent. For example, if I have x here, the degree of this x is 1, right? If I have x squared, the degree of this is 2, right? If I have x to the power 3 plus x squared, the highest degree here is 3, right? The highest degree in this case is 3. If I have x to the power 4 plus x cubed plus x to the power 5, so the highest degree here is x to the power 5, right? So the degree we're talking about that exponent. So we're looking for the highest degree. Which one is the highest degree? Okay. Now, we're saying p of x and q of x are polynomials, and the degree of p of x is smaller than the degree of q of x, right? 2, we now factor the denominator, meaning we factor the q of x, simply because the degree of this is smaller than the degree of that. We factor the denominator, right, as completely as possible. You factorize completely, right? Factorize completely in this case. Then each of the factors in the denominator, we can use the following. Number 1, if you are given f of x and the factors as x plus minus a, x plus minus b, x plus minus c, right? You can rewrite this as a over x plus minus a plus b over x plus minus b plus c over x plus minus c, right? This is how you can do it. Right? If you're given something like this and you are able to factorize completely, then those factors you can say a over x plus minus a plus b over x plus minus b plus c over x plus minus c, right? Then 2, you can, if you're given f of x, try to minimize space. This is x to the power x plus minus a cubed into x plus minus b. Given something like this, you can rewrite this as a over into x plus minus a, right, plus b over into x plus minus a squared plus c over into x plus minus a cubed plus d over x plus minus b, right? This is how you'll go about doing it. If you're given f of x over into x plus minus a, close bracket to the power 3. This is how you can use partial fractions to separate this fraction, right? And then 3, so now you're given f of x. Divide by into a x squared plus b x plus c, right? And then we are given x plus minus d, right? So you're given something like this. You can rewrite it as a x plus b over ax squared plus bx plus c plus c over x plus minus d. Now, with this one, do not forget, with this one, when it comes to this one, option 3, you can only do this when ax squared plus bx plus c it cannot be factorized. Cannot be factorized. You cannot have factors for this. If you can't factorize this, then therefore you do it like that. Right? These are your partial fractions. That is how you can do it. If you can't factorize it, don't forget, if you can't factorize it, then you can use that format to use partial fractions, right? Let's get an example. Let's see. Okay. Let's see. What's happening? Just give me a second. Okay, let's see if I have an example here. So let's say, let me just go to the next page and do this example on the next page. Say you are given x plus 7. Divide this by x squared minus x minus 6. Right? So you want to split this into partial fractions. You want to do it in partial fractions. You can see that the degree here is 1. The highest degree on your numerator is 1. And the highest degree on your denominator is 2. So it means this degree here on your numerator is smaller than the degree of your denominator. Then we can now try to factorize this. Let's try to factorize it. X plus 7 over, let's see if we can have vectors, x, 3, and 2. Which one is positive, which one is negative? This is negative and that is positive, right? So these are the factors that we have. And then from here, you can say x plus 7 over x minus 3. This is equals to, okay, x minus 3 into x plus 2. This is equals to a over x minus 3 bracket plus b over x plus 2 bracket. Right? So from here, you can try to remove this denominator by cross multiplying. So this would be x minus 3, x plus 3, x plus 2, not 3, x plus 2. Even this side, you do the same. X minus 3, x plus 2. And then this and that will cancel. You'll be left with x plus 7 is equals to. Now, when I say a over x plus 3, this multiplied by that, it's going to be a over x minus 3 into x minus 3, x plus 2, plus b over x plus 2 into x minus 3, into x plus 2. Right? You can see that this one and this one will cancel, and then you'll have x plus 7. This is equals to a into x plus 2 plus this and that will cancel. This will be b into x minus 3. Right? This is what we have. Now, we use the elimination method. From here, we use the elimination method. We can eliminate a when this bracket is 0, a will be eliminated, and b will be eliminated when this bracket is equals to 0. How do you make sure that this bracket is equals to 0? Let's start by eliminating b. Eliminating b, I'm gonna let the bracket x minus 3 be equals to 0. Then x is equals to 3. Now, when x is 3, 3 minus 3 is going to be 0. Let's substitute. Where there's x, we substitute 3 plus 7 is equals to a into 3 plus 2 plus b into 3 minus 3. Right? And then 10 is equals to a into 5. You can see that this will be plus b into 0. B is out. I'm left with 10 is equals to 5a. Divide by 5. Divide by 5. The value of a will be 2. Right? That is how we eliminate b. After eliminating b, we can eliminate a by saying let the bracket next to a, which is x plus 2, we equate it to 0, and then x is equals to negative 2. Right? Let's go to the next page. Right? So, we know that x is equals to negative 2. Right? We have x plus 7 is equals to a into x plus 2, and then plus b into x minus 3. Now we substitute. Where there's x, I substitute what? Negative 2 in this case. Negative 2 plus 7 is equals to a into negative 2 plus 2 plus b into negative 2, negative 3. Then I have 5 is equals to a into 0 plus b into negative 5. Then 5 is equals to negative 5b. Divide negative 5, divide negative 5. The value of b is equals to negative 1. Right? Now, I can come back and substitute it on my value of a and b. On my value of a and b, remember I had a over x minus 3 plus b over x plus 2. Right? When I rewrite this, this was given as x plus 7 over x minus 3, x plus 2. When I rewrite this, it will give me a, I got 2 over x plus x minus 3 plus negative 1 over x plus 2. Now, that is my solution for the partial fraction. That is my solution for the partial fraction. Let's try to get the next question or the next example. Okay, say you're given 3x squared plus 4x plus 4 over x to the power 3 plus 4x. Right? So in this case, the first thing to do, I can try to factorize the denominator by taking out the common factor, which will give me 3x squared on top plus 4x plus 4 divide by x into x squared plus 4. Right? You can clearly see that this, I cannot factorize this. I cannot factorize this. Then I'm going to use option 3. Right? I'm going to use option 3, which says if I can't factorize this, I'm going to have, let me write it here, this will be equals to a over x, right, plus bx plus c over x squared plus 4, right? And then when I cross multiply by that, let me try to do it. I have 3x squared plus 4x plus 4 over x into x squared plus 4. I'm going to cross multiply by x into x squared plus 4. This is equals to a over x plus bx plus c over x squared plus 4. What I do on my left hand side, let's also do it on my right hand side, meaning I'm going to cross multiply by x into x squared plus 4. Right? When I do that, I'm not going to do all the steps now. This and that will cancel. I'll have a into x squared plus 4. Then plus this and that will cancel. I have b x plus c into x. Right? So in this case, I can't eliminate. I can't eliminate in this case, so I need to expand. Expanding, I'm going to have ax squared plus 4a plus bx squared plus cx. This is what I have, right? That is a. Okay. Then this side, I have my 3x squared plus 4x plus 4. That is what I have. Now, I'm going to say the ones that have x squared, take them out. The ones that have x squared, take them out. This side, I have 3. This is equals to, this side, I have a plus b. I can't solve anything here. Then, I'm going to take the ones that have x. The ones that have x, this side I have 4. This is equals to c. Right? Means c in this case is equivalent to 4. Then I'm going to take the constants. The ones that have constants, this is 4 this side. This is equals to 4a. Then when I divide by 4, I can get the value of a as 1. Value of a is 1. The value of c is 4. Now I'm looking for the value of what? The value of b. The value of b, I'm going to say I have 3 is equals to a plus b. Then a is 1. 3 is equals to 1 plus b. Therefore b is equals to 3 minus 1. It is 2. Right? I got the value of a, 1. I got the value of b, 2. I got the value of c as 4. Now we substitute. Substitute it here. I have a over x. Okay. I have 3x squared plus 4x plus 4 over x into x squared plus 4. This is equals to a over x plus bx plus c over x squared plus 4. Then substituting a, I got a as 2, a as 1 over x plus b, I got 2x, c, I got 4 over x squared plus 4. That is my solution. Those are my partial fractions. Don't forget to like, subscribe, and share the content with your friends. See you in the next video. Tango means thank you. Tango!